Centripetal acceleration. What is centripetal acceleration? Rate of change of direction of linear velocity or just linear velocity. Is called centripetal acceleration. So acceleration is delta V upon T. Now, because when object is in circular motion, as we saw, it's at different points. Suppose object initially at this point, then moving at this point, in between, even at this point. We know that, and it's moving like this. So we know that its direction of velocity is continuously changing, something like this. At every point, its velocity is changing. And this change in direction of velocity is causing acceleration, because we know whenever velocity changes, acceleration is there. This is the case where you know that acceleration is equals to rate of change of velocity rather than rate of change of speed. Because if you say acceleration is rate of change of speed, speed is constant here. Object, suppose, I don't know, maybe 5 meters per second speed, 5 meters per second, 5 meters per second. At every point, speed is same, but it's still accelerating. Why this is so? Because of the change in direction. Now, this is different as we usually do for acceleration. If you are asked to calculate acceleration, what you do? V minus u upon t. And V and U are the magnitude of velocity. Be focused, please. This is very important. V and U are the velocities. Now, if are the magnitude of velocity, normally we take, right? So if I put velocity 5 here, suppose this is U, this is V, or maybe this is U, and this is V. Both are 5. If I put 5 minus 5, 0, my acceleration is 0. So here it comes that acceleration is the rate of change of velocity. You cannot simply plug in the magnitude when direction is changing. If object is moving in one direction only, then you can put the magnitude because direction is same, so it doesn't matter. But if direction is changing, you have to do the vector subtraction. V minus U is vector subtraction that we did in AS. How it is done? Very easy. You have done it in your AS. Suppose you just take this velocity as initial velocity. I'm drawing it here. This. You'll draw a 5 centimeter or a 5 millimeter line, 5 meters per second corresponding. Then when you want to add two vectors, what you do? You place the vector on top of each other like this. You place the other vector here. But when you are finding the difference, what you do? You place or you join the vector tail to tail. If you remember, you have done this in your AS levels. If you want to join, suppose this is your initial velocity and this is your final. These two velocity you are considering, the U 5 meter and the V 5 meter per second, but their direction are different. If I ask you, add these two velocities, what you will do? Just add, you will place the second velocity on the head of the first. And this will be your resultant. This you have done in your AS. Remember, what is this? To add this and this velocity. You can do this. But here it's different. You need to subtract the two velocities, not add. If you want to subtract, what do? You join the vector like this, tail to tail, like this. And the length should be the same. If it is 5, it should also be 5. The difference is this. This is delta V or V minus U. This is your U, this is your V, and this is you have V minus U. So look at this vector. This is the importance of vector subtraction and vector addition that you did in your AS. Without vector, you cannot find out the acceleration here. Look, this vector V1 is 5, V2 is also 5, but because of their different direction, you are getting their difference. You're getting their difference as delta V is equals to V minus U. Got it? Now, how to find out this delta V? This is the angle theta, suppose. What is this angle? This angle theta. This is angle theta. Oh, I want to remove that. Okay. This is angle theta. Now, if you do a little geometry, this angle theta is same as this angle theta. So how to find out this delta V? Now you can consider this as a small arc because it is so small. It is so small that you may consider it as arc or a straight line. Both are the same thing. Delta V is V minus U. You may consider that it's not a triangle, it's an arc. Remember, a sector. So you can apply formula S is equals to R theta here. What is S? This S, delta V is S. What is R? R is V. And what is theta? Theta is theta. All right. Just compare this. If this is arc length, this is S, this is R, and this is theta. If you compare the two diagrams, the length of the sides, that is the speed V, is actually the radius. The delta V is the arc length, and theta is theta. So S is equals to R theta will become delta V is equals to V theta. Whenever theta is small, keep in mind, there is no difference between a triangle and an arc. If theta is small, both are same. Because, a small part of an arc is always straight. Whenever there is a curve, if you consider a small part of it, it may be considered as straight. So there is no difference between a triangle and a sector. So now we have this formula delta V equals to V theta. Centripetal acceleration is delta V upon T. I can put here V theta upon T. Got it? Delta V is V theta. Now it becomes V omega. So this is the formula. Why? Because theta upon T is omega. So this is how you find out the magnitude of centripetal acceleration by this formula. Now you only need magnitude. Now you don't need the direction anymore. V is the magnitude of speed, which is 5 throughout, because you're not using any subtraction or any addition now. So that's why vectors are not needed anymore. You just plug the value of V, which is 5, omega, whatever it is, and you find acceleration. You can have few more equations. If I put V is equals to R omega, just one more minute, this will become acceleration V square, sorry, R square omega. If you put R omega square, if you put R omega instead of V here, just put R omega. So omega into omega will be omega square. So you have R omega square. If you put omega is V over R in the same, your acceleration would be V square over R. Just look. How come? V as it is, and instead of omega, you have put V over R. So V into V would become V square over R. So these three are the formulas for centripetal acceleration and for the magnitude of centripetal acceleration. You don't need vector addition, vector subtraction anymore. You can directly use this formula, but you must know this derivation. This is vector subtraction and how you do it. Yes, guys, any question? You can ask me quickly.